Okay, hi, I'm James King. I run system software architecture in the open source software group at ARM, and today I'm going to talk about trusted firmware. This was labelled as trusted firmware M. The majority of the talk is about that, but I'm going to talk about trusted firmware in general as well, and some of our plans around open source project. So, thank you all for coming. This talk, I'm going to briefly go over what trusted firmware is again, for anybody who doesn't know. Talk about what we're doing that's new here. Talk a bit about platform security architecture, so that's an important part of our plans. Talk about what we're doing in terms of making the software open source and available for you to use and for you to work on and contribute to, and then where you can learn more. Okay. So, for anyone who doesn't know, trusted firmware is basically a set of software components we provide, which provide the foundations for creating a secure platform. We provide reference software for the partnership to use, which will allow you to use your hardware to create a properly trusted execution environment for secure software to run in. The trusted firmware provides an example of secure function invocation. There's a lot of people still coming in. Sorry, I started. Device initialization and setup, so that you know that the software that's running in your trusted execution environment is actually secure. And of course, trusted boot to verify that the software that you're running is the software you expected. Trusted firmware is also going to provide a reference for PSA compliance. I'll talk more about that later on in the talk. And ARM's goals here, by giving away this software, is kind of threefold. We want to help out the partnership to use ARM CPUs, ARM hardware, minimise the production effort required to move to new CPUs to implement good security on your products and devices. As a benefit to ARM and a benefit to the wider software ecosystem, we want to standardise the interfaces used for invoking secure software, make sure that applications that are written for trusted execution environments and other security features are easy to integrate, easy to port across different devices, and generally improve the software environment on ARM processors. And then, of course, by being standardized, by everyone using the same trusted firmware, we get improved security by scale. If somebody finds a vulnerability somewhere and we fix it here, then it's fixed for many, many devices, many, many partners, and in a way that can be verified across lots and lots of different devices. The almost opposite of that is that the same software is used in lots and lots of places, so it gets tested a lot more, and people try and work out vulnerabilities and exploits, and so the two together improve security by scale. Okay, so for many people here at Connect, trusted firmware is not new. It's a reasonably mature open source software project that ARM's been doing for the A-profile CPUs since 2013. The link is the oldest video I could find from Linaro Connect, which was in Macau in 2014 with Andrew Tolkey talking about ARM trusted firmware, as it was called there. I think there were talks older than that, but I just couldn't find the videos on the internet. It's a well-established collaboration model. Has the usual things you would expect of secure firmware, security incident handling. It's been hardened for security with certification, MISRA hardening. I mean, this is all ongoing work, but it's a pretty mature software project, and actually is used in most production A-profile systems for V8A across the world. And just to further reiterate this, I think this was shown by Matteo in another presentation already this week, but it's still an ongoing project. I mean, the latest release has got new features around partitioning, around RAS, updates to PSCI and SMCs. It supports all of the ARM v8A systems, and actually support is in there for older systems as well. And just to give a bit of a quick overview, it provides a trusted root of trust ROM implementation, a trusted loader implementation, and then runtime firmware that will load your TEE and your non-trusted software once it's been verified as okay. And so, I mean, basically this flow here kind of shows the three things that actually makes a trusted execution environment, in that you need to securely boot on hardware that has secure features, and then put in place a trusted OS that has been verified to run there. And actually, this software supports all 12 global platforms compliant TEs on the ARM socks. Obviously, Opt is the best one. And, but it's, I only said that's Joachim's stat right in front of me. But what is new is trusted firmware on the M profile systems. So building on the terminology, the principles, the understanding of trusted firmware that we've worked on for a long time, we've taken that learning and created new trusted firmware for the M profile CPUs, the much more embedded space, which again provides isolated secure and non-secure execution environments, methods to invoke secure software, and then trusted device initialization and boot to, in the same way, create a valid and trusted execution environment. The important thing about the M profile systems, and the reason it's different code, is they're more constrained devices. You have to do things in a different way to be able to fit into the much smaller amounts of RAM and flash that are available. The M profile CPUs actually have quite a different mechanism for trust zone isolation. The A profile processors use SMCs in a kind of exception model to move between secure and non-secure world, whereas in order to make things smaller and cheaper in the M profile systems, it's more of a address space isolation that's used. And then the other thing that is actually very important when you're creating this foundational software is that the software ecosystem for the M profile systems is much more fragmented, and it needs to be easier to be able to port lots and lots of different OSs and software above it. One of the things about this new trusted firmware, though, is that it's not yet PSA compliant. It's the start of a journey, and as you could see with the A profile trusted firmware, that journey's been going for many years and is still going strong, and we expect this to be the same with the M profile trusted firmware. There's a starting point now. It provides a good reference example to be able to implement a trusted execution environment on the M profile systems for early V8N partners, but there's still lots more to do, in particular working towards the platform security architecture, which I'll talk about now. So, the big picture for PSA, platform security. Sorry, I just got a reminder come up. The big picture is that basically it's a set of free deliverables that ARM's giving out to the partnership, documentation, threat models, and reference implementations in order for you to be able to easily create a secure system. We're starting with the M profile devices because actually The IoT space is an area which is very much needs help in adding security as these devices become more and more connected and more vulnerable to threats. So that is the area that ARM's focusing on at the moment, but the idea is that PSA becomes a standard across all the different devices. So here, these are documents that we're planning to provide. Firmware Framework specification, specifications for boot and firmware update, device initialization and secure functions. The threat models and security analyses, I'll talk about in a second, but are designed to make it easier for you to be able to adopt and work out what security you need. And then the implementations that ARM provide. Trusted firmware is a very important part of that, just here, and is really designed to implement the specifications and address the threat models. And basically the reason ARM does this and the reason ARM gives it away is actually most device manufacturers don't really know what their security requirements are. It's a difficult problem. It's not meant to be an insult saying that. There's a lot of attacks and vulnerabilities that are only known about by certain people, and the problem evolves and changes all the time. They just know what they want to be able to produce and would like ARM to provide assets that allow them to be able to focus on what they want to produce and their value add and have security just built in. And this is the whole point of basically giving 3 examples to follow. And so the idea is that anyone in the partnership can use the threat models to analyse whatever it is they're trying to produce and to be able to understand what security requirements they have. They can then refer to the architecture documents as to what needs to be implemented, and then of course use example implementations of hardware IP and software, and in particular the firmware we're talking about here, in order to make that secure device. And just a little further description on the security analyses and threat models. For anybody who's working on IoT devices now, whilst a lot of the PSA specifications are not yet public, these threat models are available now. The link's at the bottom of the page, and they're examples of the kind of things that you should be looking out for and trying to address in your product. And this varies from product to product. So, I mean, we've got an asset tracker, a water meter and a network camera, because they all have quite different areas that you want to be able to protect data and areas that you want to protect the system against attack. I mean, as you can imagine, the asset tracker doesn't actually export much data. The network camera has a huge quantity of data and needs to be treated in slightly different ways. And ARM is continuing to work on different example threat models and will continue to provide reference descriptions of the kind of security requirements you need for different segments across the entire ARM ecosystem. Okay, and then one of the specifications for PSA, one that actually some of the partnership will have seen, is Firmware Framework, which is hugely relevant to producing trusted firmware, as it describes the ideal attributes that your firmware should have in order to maximize the security of your system. You want a non-secure processing environment, which is where the bulk of your code runs. It's normally quite important to help with your security to only put the code that needs to be secure into your secure processing or trusted execution environment. Within the firmware, we'll are creating partition management. That's going on both in the A profile firmware and in the M profile firmware. It's not fully implemented in the Trusted Firmware M at the moment, but the idea of the partition management is that you can take different secure functions and isolate them from one another, different trusted functions. If you're creating a device and you get some secure software from a third party, you might want to isolate that from your security features, your root of trust features that you've gone and implemented as the silicon manufacturer. And of course, it may be that you trust some of the code between some of these, but you particularly don't trust something that is provided as a binary that you need to run securely to be able to meet some kind of certification, but you want to make sure that your features are protected from it. PSA is also defining standardized interfaces for software. Quite importantly for the ecosystem are a bunch of security APIs. I'll list them on the next slide, which should make it easier for people who are writing applications that need secure functionality to be able to invoke them. I think a great example of this is the increasing numbers of security features that cloud clients require in order to be able to do attestation and authentication and encryption of the data. The other things that are in the API specifications is an IPC, an SPM specification for the partitions and secure functions and trusted functions to be able to talk between each other and to be able to be talked to from the non-secure side, and specifications as to how to invoke your secure hardware, which is also described by the TBSA for the M profile systems. That's also being produced by ARM. And again, whilst I'm describing this, I mean, the important thing is that trusted firmware isn't there yet now. We're working on it. And so the plans for this year on the code that we're making available is align with those specifications as they get finalised. If you're interested in the specifications, contact your ARM partner account manager, and I'm sure they can help you get access to them. But in terms of the open source software and what ARM's software development team will be doing, a large amount of what they'll be contributing into the trusted firmware this year will be the standardized APIs, such that your applications can call on crypto services, attestation, secure storage, the other APIs described here. We're completing the secure partition manager and IPC. At the moment, the code that's available has a very constrained model for the trusted execution environment that doesn't partition it up, but the partitioning is coming soon. Continuing to work on device initialization and trusted boot and firmware update, and of course make sure that it's easy to build different configurations of this firmware within your system to address the threats that you identify for your system. As with the A-profile trusted firmware, it may be that there are certain things and features that you don't want. This is reference code that you can use however you want to use it, and whatever's appropriate for your application or device. We're also working on supporting ARM development platforms. I mean, at the moment, the code runs on the Musca test chip. This is a Musca test chip, which is a ARM V8M development board. Again, actually, ARM will give these out on loan agreements for free to any of the partnership. Contact your account manager or get in touch afterwards. We support FPGA systems. There's the MPS2 and MPS3 boards that ARM has been providing for ecosystem development and IP development for some time, and the SDK 2.0 at the moment. And the AEM V8M fast model, which again is a free fast model that you can get from developer.arm.com. I believe we'll soon be adding in QEMU, and obviously we'd like to be able to add in partner SoCs via contributions into the code base. We're also working on developing for ARM IP, so crypto accelerators, secure enclaves like the ARM Crypto Island, and the system IP that we provide as part of the larger V8M picture. But as I said, what we'd really like to do is to be able to support and encourage and enable other people to contribute to widen the ecosystem here. The partner SoCs and boards as described, and also software services, features, RTOS, secure software interfaces that make it more applicable wider and wider across the ecosystem. And we're going to do all of the work that the ARM engineers are doing, of course, all in public, all in the open source project. So, just going to change tack a little bit. So, as I described earlier, the A-Profile trusted firmware has been publicly available on GitHub for many years, and actually that's been working quite well as an open source software project, and we've had many contributions into there. I mean, HiSilicon, MediaTek, NVIDIA, Linaro, Socionext, Xilinx have all contributed into the A-Profile trusted firmware. But we've had quite a few requests to be able to move this software into a more open governance model. If you're a silicon manufacturer and you use ARM's trusted firmware, you depend on it. People want to be able to feel more ownership of the software. And so it has been requested that we move to a more open governance model for the trusted firmware. I think this also creates a message to allow more of the partnership and more of the software ecosystem to participate and to actually steer the direction of the trusted firmware in ways that can help us all. At the same time, Linaro is creating a community projects division. And basically this is a part of Linaro that will host open governance, open source software projects. The projects are operated independent from Linaro, so this is not under the normal kind of TSC and Linaro management. But each project would have its own board, and if it wants them, committees and funding and URLs. Linaro, as its community division, is basically contracted to provide the IT infrastructure, finance, legal, marketing, engineering if the project wants it. But it's not actually managed by Linaro, it's managed by the board. They are just providing these services. Project membership is open to anyone who wants to join, and for each project there are board members and then there are general members who can join and help to steer how the project goes and how investment in the project goes, what we do in terms of CI, what kind of platforms are supported, and what kind of strategic directions we take to widen the applicability of the project. And so bringing both of these together, we actually get a new open source project, trustedfirmware.org. That's the homepage of the website. To be honest, it's pretty much just a stub there at the moment telling you where to contact to get more information, because we're in the formation phase of this project. But the infrastructure is live now. So Linaro's gone and put together, there's the Git server that I was actually showing just before this presentation when I was showing Joachim's contributions. Gerrit review server for patches to be pushed to. For anyone who's not going to use it, Gerrit is the code review system that Google use for all of their software projects. And an issue tracker for people to be able to log bugs, request change requests, and bring up any other kind of issues. The code base itself contains instructions for contributions. It's a normal DCO signed off type contributions. There's no CLA to be signed. It's very similar to contributions as they stand now to the A profile trusted firmware. There's maintainer files which describe who are going to be the appropriate reviewers if you want to contact them in advance for something that you're trying to do. Just looks like a normal open source software project. The M profile trusted firmware is there now and ready to take contributions as of today. The A profile trusted firmware is also there now as a clone of the GitHub, and will be transferring the processes and mechanisms for that project over the next few months. And so really one of the main reasons for this talk is to request that you get involved. There are memberships available. Platinum is board membership, general membership, community memberships. Linaro and ARM are starting to present joining this open source project to various potential members in the partnership. You can take partial ownership of a project you depend on, make sure that your test boards, your devices, your software tests are included in the CI system, are fully maintained and looked after, and therefore hopefully overall reduce your costs to producing new systems, and obviously help ensure that that the open source community maximally supports trusted firmware, that it gets supported by other open source projects that connect to it, and becomes a de facto standard to make all of our lives easier for software development. And there's an email address there to contact if you want more information, or I'm sure you can find me or Rob Booth or Steve Taylor, and we'd be happy to talk to you about getting involved. If you want to learn more about the M profile trusted firmware, there's 3 deep dives this afternoon. Miklos, Ashutosh and Tamas, who are all in here, will be presenting a lot more detail on the new trusted firmware that we've made available this week, later on this afternoon. And they are working with the Light engineers in the Light hacking room this week to be able to demonstrate Zephyr running in the non-secure partition of on test platforms, which I believe is certainly working and will certainly be demoed on Friday now. So that work's been going really, really well, and that only started yesterday, and hopefully that's a good indication of how easy it should be to integrate your normal non-secure software stack that does the functionality that your device does into the security framework that adds in all of the security features that we've been talking about here. Okay, so that's all I was going to talk about here and now today. We've got time for a few questions. If you want to know more about what's going on with the code and how it works and things like that, feel free to go to the Light hacking room and find one of the engineers. Could make you all stand up. It's, just before you ask your question, Ashutosh, Miklos, Tamas, do you want to just, and Abhishek, you can stand up too.
All right, you're looking behind you to make sure.
Yeah.
If you see any of these people, they can talk to you about the code as well, and then you can sit down now. It's fine. Obviously you can email the board address for details about joining the project, or I'm quite happy to receive any kind of queries directly myself. Okay.
So yeah, I've been looking at the code and done some work, but you're required to run ARM client. Will that change to run GCC in the near future?
Yes.
Do you want to take the mic?
Yeah, so we did realize that when we were making it open source, we need to make sure that it's not just the licensed proprietary tools, but also the free open source ones. So we got the GCC patch ready inside now. Okay to share in the light tracking room the instructions, but just to put it in the project is just going to take a little bit of polishing it up and then putting it there. Yeah, it does work, so it's been sorted out.
Thank you. And I mean, as I said, this is very much the start. We've actually tried to make this public as early as we can, when it's working well enough for us to be able to demonstrate the features. But before there's lots of functionality that we know we need to add, but making it public early is generally a good thing to be able to do those features in the right way, in the right direction.
So another question: how come you are moving away from GitHub to Garrett? Is there any? What's the rationale?
So GitHub is great for being able to manage lots of open source projects. It does have some features that annoy some developers. It's very, very good if you're doing small projects where you have somebody putting their code available, and it's mainly people who are downloading and copying their code and doing something else with it. But as a collaborative, large-scale software development, it's not as good as, say, the way the Linux Foundation hosts Linux. I do appreciate that Gerrit as a review system has people who like it and people who don't like it, but I mean it's a very well supported, well documented and capable review system that allows us to do lots of features in terms of integration with CI and things like that that a mailing list wouldn't. And so it's really some small reasons, and obviously if you're creating a project that's running itself as a full open source project, actually being able to put things on your own URLs and for the project to properly own it is a nice thing as well.
Thanks, Mark.
I have two questions, if I could be so greedy. The threat model and security analysis currently doesn't include anything with actuators, really. Are you planning in the very near future to release something that involves like an actuator? Like, I know you're not doing industrial control systems, it's not SCADA, but you know, connected kettles, connected coffee machines, things with heating elements, and you know, is there any plans for that? Or
yes, I actually don't have the list of ones that are specifically being worked on at the moment, but as you've asked this question, I will feed that into the people who are actually doing it and make sure that there is an example to that effect. I mean, basically, as you can imagine, there's probably 200 or 300 classes of devices that use ARM processors that actually do have threats and security requirements, and so the initial 3 that have been made public they were only made public for Embedded World 2 weeks ago. And so that is, again, work that's very much ongoing, and I'll feed that in. And they were just trying to show quite different types of systems where the requirements are quite different. In the end, as you do more and more of these examples, the Venn diagram of the requirements overlaps more and more in all kinds of different ways. But I don't have the list of which ones are coming next, but I will feed that back into the people who are doing it.
And my other question was whether there's any plans for a IoT systems guidance virtual platform at all, with a Cortex M in it.
Oh, no. I guess, well, okay. So, system guidance platforms, for anybody who doesn't know, are examples of how you put together a mobile or an infrastructure chip based on ARM's guidelines with lots of information about the performance that you would expect, about various ways of integrating, and then they came with an example fast model and an example software stack. In the embedded space, we do things slightly different in that there's the SDKs that we produce. We provide FPGA images of those rather than the fast models, and we provide example software. So in that respect, they're quite similar, but we're actually providing the full RTL, and so it's not a guidance, it's a development environment. So in terms of the software aspects, we provide a reference system that you can run reference example software on. And in that respect, it's quite similar, and that's what we already produce for the MPS2 platforms, the SDK200, and the Musca test chip is actually just an example of that. I mean, that's a SDK200 with some stuff around it pushed into silicon. So from a software perspective, they're similar, but it's more of a actual implementation, go and take all these bits and use them, than a guidance as to how you would create your own chip.
Thanks.
Does that make sense?
Yeah.
So my question is, if the new Git repositories maintained by the Trust Firmware organization for different boards are ready, so the original ARM Trust Firmware Git repository will continue to be maintained or not?
So we're planning to transition the existing A profile code from GitHub to this new Git repository over, I would say, hopefully by next Linaro Connect. But it's still running in the GitHub at the moment, and we will make it quite clear and put deprecation notices and announcements about moving it across. Is there a concern about moving the code from the GitHub to justafirmware.org?
I don't have a concern. So that means for TFM, we will not have independent Git repository maintained by ARM, but we just move to the Linaro Trust Firmware organization.
Yeah. So well. And it's the trustedfirmware.org project. Linaro is managing it in its community projects, but and Linaro plans to be one of the board members. But yeah, I mean, it's not a Linaro project per se. It's a community project. But yes, TFM. We did an early access release to the M profile trusted firmware on GitHub for some partners to give early feedback, but that GitHub is being basically stopped for contributions, and everything's moving to the new location, and and so all contributions will start for the M profile code there, and like I say, for the A class A profile code, we'll move to it as soon as we can. Any other questions? Yeah, he's going to ask something silly. Okay, in which case, thank you all very much. Look forward to hearing from people who'd like to be members, and you all attending the more deep dive later on this afternoon. And I mean, with all your support, hopefully this can be a massive success and continue to be so for many years to come. Thank you.